In the past, we taught this as two separate lessons and it had word problems, which I'm not saying word problems are bad, like they have really good like real world applications and things. But for this lesson, all you really need to be able to do is given an equation with more than one variable, still be able to solve for a particular variable. So kind of like we did in the Kahoot today, which I think really drew that together. And I forgot what this equals, so I'm gonna make up a number. It may or may not work nicely. All right, but what we're trying to gear you up toward is when we're having to graph things in slope-intercept form and solve systems and things like that. Slope-intercept form, we haven't discussed yet, but you might be familiar. It's the y equals mx plus b. What is alone in y equals mx plus b? The y. So if I want to be able to graph something in slope-intercept form, I need to be able to isolate y. Whenever you're isolating a variable, what do I tell you to get rid of first? The number farther from the variable is what you get rid of first. And when I say variable, I mean the one we're specifically trying to solve for, the y. So what's farther from the y, the 2 or the 4x? 4. And how do you cancel that out? And because if I want the y to be alone, I basically want this to be plus 0, so that way I don't have to write it. People get confused. They like want to divide 4x. That would cancel it to 1, not 0. I want it to be 0. And then whatever you do on one side of the equal sign, you do to the other side. So on the left side, this goes away. We don't write 2y plus 0. We just write 2y. Are these like terms? No, one has a variable, the other does not. I am writing it so that this is first, kind of like our mx. The 4 is still negative, the 20 is still positive. Now, what's opposite of multiplying by 2? And whatever you do one side, you're doing it to this entire other side, which would be the same as if I split it up between that term and this term. That's what I'm going to do. I get y equals what's negative 4 divided by 2. So that becomes negative 2x. And what's 20 divided by 2? And then now that's something in slope-intercept form that I can now do other things with. And that's what we're leading you to. So it's really hard. Like if you can't rearrange equations, it's really hard to move on from this. Okay, so try to like really understand it, try to ask a lot of questions if you don't, but the steps are the same as when we're just isolating variables. There's only one variable involved. So you have to be able to write an equation that describes a situation where there's multiple variables and then solve for a particular variable like y. Be able to know how solving for a variable can be used to quickly calculate the values of that variable. So you have 2 practices that will help you with that. Of course, it might be easy to get answers from your friend, but try to understand it yourself. If you don't understand how to do something, you should probably ask. You can ask your friend and we can explain it to you. Don't just ask for the answer. Just give your friend the answer. Side note, if you have a low grade in here, it's probably because of that coloring activity being a low grade, or you just not turning it in at all. I mean, there's some that were resubmitted that I'll need to regrade, but if you haven't resubmitted it, you might want to make that a priority today too. But since you're all here, I'm holding you to this being at 80% or higher for the curve. And then I would recommend resubmitting this if you have a low grade in here. Kind of think a lot of these grades. Any questions? Okay. Should you need anything as we go, let me know. When Cadence comes back. So we're on lesson 2.08, number 1. Here is a linear equation in two variables. Solve the equation first for x, meaning that we want the x to be alone on one side. The way that this is set up, it looks like they want it on this side, but the other side would have other stuff with it. But when you are isolating a variable, start with what's farthest from it, but still like on the same side of the equal sign. What's farthest from the x? The 31, and how do I make it go away? In this case, I would add. You want it to be where it would cancel. So the way it would cancel is by adding 31. And whatever you do on one side of the equal sign. So that will cancel out this. So far I have 2x plus 4y equals, these are like terms, all single numbers are like terms. What's 123 plus 31? Okay, so now we are still isolating x. Would I get rid of the 2 first or the 4y? What's farther from the x? The 4y. And the reason I say those together is because sometimes people get confused and they want to like divide it or something to cancel it out. Remember, we're isolating the x. If I want this to go away, it needs to say like plus 0, so that way I don't have to write it. How do I make the 4y 0? Subtract it, and whatever you do on one side, do to the other side. I get 2x equals, these are not like terms, so don't try to combine them. The way that this is set up, it looks like it has the constant, like the single number second, so I'm gonna write it like that. I'm gonna write it as negative 4y plus 154. I'm allowed to do that because the 154 is still positive, the 4y is still negative. Everyone with me so far? Okay. X is almost fully isolated. What's opposite of multiplying to? Whatever you do on one side. And we're doing it from both terms. I could write it as just one big division sign divided by 2, but you have to remember, like, you can simplify those numbers. You can do negative 4 divided by 2. What's that? Negative 2. And then the y goes here because that's what it's in front of. And what's 154 divided by 2? 77 is correct. So then the way that they have it set up, you have to follow this structure where the constant is second. And then yeah, that is correct. Any questions on this one? Yeah. Questions on this? Questions on others? Number 5 on lesson. Number 5 on lesson 8. Okay. So we are going to select all equations that are equivalent to 3x minus 4 equals 5. So kind of a bit of review, it's not directly from this lesson, but you guys should still be able to do it. I don't have another one on me. Here. Okay, so we're selecting all that are equivalent to 3x minus 4 equals 5. That means if I can manipulate it to get one of these answer options, then they are equivalent. So just try to keep an eye out for what's different. So like what's different between the original and this first one? It's just 3x. How would I make the 3x be alone in the original? Adding 4 and whatever you do on one side. So when I add 4 to the original problem, that would get me the 3x alone, and when I simplify, what's 5 plus 4? So that is equivalent, because I can manipulate it to get the other. So far, that one's an answer. We need to select all. So, and then see the second one. What's the difference between this one and the original? There's a what? There's a plus 4. This part's the same as the original. This part's different. It's a rule that you can do whatever you want so long as you do it to both sides. Did they do it to both sides? Add 4? So then I can take that one. Over here, what's the difference between this one and the original? Be more specific. There's no 3 in front of the x. How would I make the 3 go away? In this one, the only way to make the 3 cancel out would be to divide by 3. Is that what they're doing over here on both sides? Is 2 what we get from 5 divided by 3? So don't pick that one. There's no math you can do to make this one, that one. Okay. Now, the next one. I do know that we said this one was equivalent. This one has it fully solved, so let's solve it. What's opposite of multiplying 3? What are you doing on one side? And x equals, what's 9 divided by 3? Or sorry, 9, yeah, 9 divided by 3 is not 9, right? So don't pick that one. What's the difference between this one and the original? Well, this is a -4 on the left, so I guess that part is staying the same. What's different? What's missing on the left? And how would I move the 3x? What would I have to do? And whatever you do on one side. Now these aren't like terms, so that's why they wrote it like this. And you know, their math is right, so that one is equivalent as well. Because you can manipulate one to get the other. So questions on that? Questions on others? Massimo? Say something to me. So Han is solving an equation. He took steps that are acceptable but ended up with equations that are clearly not true. This is almost like what we did in our notes. So you can see like he got 0 equals 1, that's clearly not true. And we're gonna see the rest in a second. We probably have to read this multiple times, that's why I'm saying. It says, what can Khan conclude as a result of these acceptable steps? So they're not asking you if he made a mistake. They're saying that the steps he took are acceptable. Hopefully you should know if they're acceptable or not, like from your steps that I taught you. But they're not asking you if he's wrong. They're saying his steps are acceptable. So what does it mean when we end up with something that's not true? Where the variable canceled out and we get something that is not true. Better. There's no value that can make it true. There's no solution. So the answer option that says that is that one, but let me read the rest. Yeah, no, there's that. If the steps are all acceptable, which I'm kind of confused here because I think it should be say 6 equals 5 right there. But either way, it's still something that's not true, and that means that there's no solution. 0 and 1 are solutions, so if there's no solution, it can't be those. And it's not any value that's So questions on this one? Okay, make sure that Brett repeat. Questions on any other? Cadence? Sorry, one more time. Number 2. On 11 and 8? Yeah. So. The chef bought 1701 worth of ribs and chicken. Ribs cost $1.89 per pound, chicken costs 90 cents per pound. This equation represents the relationship between the quantities, and we're going to rearrange it to solve for C. So if we're solving for C, we want the C to be. If we're solving for C, we want the C to be. When we're solving for any variable, we want that variable to be alone on one side. So this over here, that has an expression that would go there, but like there's one thing that would go here. This would have to be the C if we're solving for C. Now, for the rest, you have to do your inverse operations, starting with what's farther from what you're trying to isolate. What do I need to get rid of first? What's farther from the C? And how would I make that cancel out? And whatever you do on one side. Okay, great. This cancels. I get 0.9 C equals, are these like terms? So you cannot combine them in any sort of way. The way that this is set up though, again, it looks like it wants the constant to be second. So I'm just gonna switch the order. I'm gonna make it negative 1.89 R plus 17.01. You can do that so long as you keep the signs the same that are in front of you. All right, now look at what's being done to the C and then do the opposite. What do I need to do to isolate the C? 5.9, whatever you do on one side. And make sure you do it to both terms because there are numbers you can simplify. That's how we get C equals, and I do need my calculator. Negative 1.89 divided by 0.9. It is negative 2.1. Which is an answer option, negative 2.1 in front of the R. And then 17.01 divided by 0.9. Divided by 0.5. Yes, 18. Which is an answer option. And then it says, why would you want to solve for C? So like, I guess, what does C represent? The pounds of chicken, right? The 90 cents is how much it costs per pound. So if I'm isolating it for C, I must want to find the pound of chicken. Okay, that's on that one. Because that's why rearranging might be helpful. It makes it easier to solve for particular things, because then all I have to put in my calculator is this stuff. All right, other questions at all? Eden? Number 3. So a car traveled at 180 miles at a constant rate. Write an equation that would make it easy to find the rate at which the car was traveling in miles per hour if it traveled for T hours. So when we say easy to find the rate at which it was traveling, R. When we say easy to find, we want that variable to be alone or with other stuff. Alone, so that's what's gonna go here, you're gonna type in an R. Because if we want it to be easy to find the rate that the car was traveling in miles per hour R, then we want the R to be alone. And then the other variable they want you to use is T, so then that must mean it goes over on this side. So let me type it in and make sure the key is right. That's what you would have to do. So when we say easy to find, we want it to be isolated on one side. All right, other questions? Massimo? All right, so going to the lesson 9, the other one you were supposed to get 80% or higher on. And number 3. So we are picking which equation has the same solution as this one. So you have a few options. You could solve every single one. Or you could remember that if they have the same solution, they're equivalent equations. And like if you manipulate one, you can get the other. Up to you which one is easier. So I'm just gonna go like option by option. Is this one equivalent to the original? All right, no. There's no math. I mean, I guess technically to get rid of this, you could add X, but then you have to do it to the other side. So not that one. I can't manipulate this one to get that one. Is this one equivalent to the original, the second one? So. Yeah. I would disagree because they're switching the signs. They're making the 5 negative. And the X positive, and that's me. I don't know what math you do to get that. If there is math, I don't know. I'm gonna say that that's not an answer, and you might double back and check. Over here, this one's almost fully isolated, so let's just isolate it. What is opposite of multiplying by 9? Dividing. And what's 46 divided by 9? A decimal answer. 46 divided by 9. 5.1 repeating. Okay. In that case, let me see if this one also equals that for the X. First, distribute if necessary. I don't need to distribute in this one. Combine line terms if necessary. I do have some like terms here and here. What's 10x minus x? 9x. If I have 10 x's, I take one away, I have 9. Then I get 9x plus 5 equals 41. For isolating x with opposite of adding 5. There we go on one side. Now I get 9x equals what's 41 minus 5. Which from here, I can tell these are not gonna have the same answer. Because this at this step was equal to 46. So then process of elimination, it must be this one. Which does match this step now that I realize. Once we combine like terms, we got that exactly. So again, you could solve every single one and see what x equals for every single one and compare. Or you could just see, can I make one the other by doing acceptable math? Cadence? Okay, which one? The lesson 9 practice. Okay. Okay, so V equals pi r squared h is an equation to calculate the volume of a cylinder. It's explaining what each variable represents. Which equation allows us to easily find, meaning it wants
this to be alone on one side. Easily find the height of the cylinder because it's solved for H. So we want it to be H equals. So I can already eliminate these two answers because it doesn't have H alone on one side. All right, we're just between these two now. So look at what is being done to the H. When it's all smushed up against it, what is implied? And it's pi times r squared times H. What's opposite of multiplying? And in the same step, I can divide both the pi r squared and whatever you do to one side. So then that will cancel, and then I get the H alone. The answer that best matches this on my screen is this one. Okay. So if we're solving for something in particular, we want it to be alone on one side. Look at what's being done to it and then do the opposite. We might have time for one more if it's a quick one. Passing on the lesson I practice. Okay, so number one on this one. A car has a 16-gallon fuel tank. When driven on a highway, it has a gas mileage of 30 miles per gallon. Write an equation that represents this relationship. So, let me think. Okay, 30 miles per gallon. So as we were driving, what is happening to the gas that's in your tank? Is it increasing or decreasing? So we started with 30. It'd be decreasing by however many you are driving, right? And then I think we're multiplying it by, or am I wrong? We're multiplying it by 30 actually. Because the fuel tank is a 16-gallon fuel tank, right? And X is the amount of gas that's left in it. So that makes more sense. Sorry, I don't know. I have to look at the options and see what different costs you want in those. But that makes more sense. If we started with 16 gallons of gas. And we want to see how far we've gone. We'd have to do this.